Welcome to another Newton's second law walkthrough problems. Take a look here where you've got a girl who's pulling on a sled and they're on a frictionless surface of ice with an ideal rope of negligible mass. The negligible mass means that any force or tension is a force, is going to be the same throughout. So if you slice this rope at any single point, you're going to have the girl is pulling 5.2 to the left, but there's going to be an equal and opposite force on the other side of that rope, as long as there's tension maintained into it. And in this case, because this sled is going to be pulled in that direction, we're assuming that the tension is kept constant throughout. So to solve for the acceleration of both, we treat them as a point mass, and the girl is going to experience a pull to the right of 5.2 newtons, and the boat is also going to experience a pull of that same magnitude to the left, 8.4 kilograms. So that is going to have an acceleration, I'll call it acceleration of the sled, and this girl is going to have an acceleration, I'll call it acceleration of the girl, and we can use Newton's second law to figure out what that is. So that is going to be 5.2 newtons divided by 40 kilograms is equal to the acceleration, and 5.2 newtons and the 8.4 kilograms. And that's going to be the acceleration of the sled. Take a minute, run the calculations on that. You're going to get a small acceleration for the girl of just about 0.3 meters per second squared. And over here, 5.2 divided by 8.4, and you're going to get 0.62 meters per second squared. That's the acceleration of the sled. So we should also define direction with this one. So that one's moving to the left, and this one's moving to the right. How far from the girl's initial position do they meet? So that was the answer to A. That's the answer to B. C. Well, we know that there's a distance of 15 between them. And we know that the girl is going to cover a certain distance based on that constant acceleration from that force. So the distance the girl is going to travel, I'll call that d1, is equal to half her acceleration time squared. And the distance, I'll call that d2, that the sled is going to travel is the same idea. And notice I'm talking about distance, and I just need the distance to add up to 15. So I'm not worried about the direction of the sled because I know that it's moving towards the center as the girl is moving towards the center. 0.62 meters per second squared times squared. Well, I've got two equations there, and I know that I'm interested when d1 and d2 sum together to give me 15 total meters. Well, that's easy. I just assemble the equations together, and I have 0.13 plus 0.62 times squared equals 15. Take a second and solve that. And you should get about 6.3 seconds. So there's our time, and we can use that time then to figure out how far from the girl's initial position does she travel. So we'll plug that back in to her distance is equal to the 1/2 of her acceleration and the time squared. And you get about 2.6 meters for the distance the girl is traveling.